Welcome back, y'all. Sorry for that awkward stop there. I got my pen back and working, I think. Let's double check. Yep, there it is. All right, so let's finish this problem. We left it a really awkward spot. Holy crap. Okay, we were going to fix our answer for 3 sig figs. So I'm going to go ahead and round this one to that. And we are probably awful darn similar to which you got, even if we rounded slightly different. So hopefully we're pretty close on that one. I hope you took a minute to do that problem with me. I've posted, like I said, I've posted this blank sheet of problems up on Blackboard for you, so you can follow me along with that or try them beforehand if you want. You can even watch me do the first one, and then you'll notice we have several problems, so you can pause the first one and try the second one on your own. All right, we're not quite done with this problem yet, though. We just did the carbon dioxide, but we're also asked water. So let's turn right around and repeat. And in fact, screenshot real quick. I'm going to erase the answer because I want to write right underneath it. We're going to do the same thing again. We're just going to solve for water. And I love this example. I'm going to write here baby steps, right? Didn't we get 27.4 grams carbon dioxide? Okay. And I am going to baby steps on this one because I want moles to feel very tedious by the time you take the test. I want it to feel like you are just repeating the same thing over and over, the same process. Remember, this is just a fancy unit conversion. We're just developing our own unit conversion with our balanced reaction. So let's start this problem again. Let's start with 10 grams of methane. All right, again, we can't use the mole ratio without moles. Let's put the mole and mole ratio. So we've got to convert to moles. That part is actually going to be exactly the same. What? 2 for the price of 1. All right, here's the reason I love the mole ratio. Because if you're trying to do this too fast, or you've seen it in high school and you're thinking, Dr. A, I'm just going to crank through this. It's easy. I just divide by 2. Well, you never know if you multiply by 2 or divide by 2, or do you do it here in the formula, or where do you put the 2 for the moles? Well, that's why I love the mole ratio, because you only put that in that one spot in your math. All right, so we now we just got rid of grams of methane. We want to get rid of moles of CH4, and we really want moles of water. Okay, this is the super fun part. This is why you balance your reaction. What is our mole ratio? Let's use the pink pen. So we've got 2 moles of water for every 1 mole of methane. So there's your mole ratio from your balanced reaction. And then let's go ahead and convert your moles of water to grams of water. Okay, I love it. All right, what do we put in there? We need the molecular weight for water. So we've got 2 times our 1.0079 plus our 15.9994. All right, that is 18.0152. All right, grab your calculator. Let's do this. Let's take our 10 divided by the 16 times 2 times the 18. All right, I am getting 22.45920.237. That will be grams of water. Again, we all might be slightly off here for some rounding. I prefer to round at the end. You're going to get a better number that way. If you round at each step, you're going to carry that rounding through the whole math problem. You'll be off by a little bit. All right, how many sig figs do we want? 3. So I'm going to go up to 22.5 grams of water. Let's put that in there. Awesome. There you go. All right, so if we start from, okay, wait for it. This is going to be super fun. All right, we started from 10 grams of methane. We threw on some yoga pants and lit a candle. We found our balance. And then once we balanced that reaction, now we started some math with that. Now we could use that balanced reaction as a fancy unit conversion. And we used our balanced reaction as our mole ratio. And now we're using numbers we've already seen. You know how to calculate molecular weight. That was our first video. So you already know how to do those. So all we've added is the mole ratio in between. Okay, now we have a couple things that are equivalent. What if I were to just be curious and ask you, well, we know how much methane, we know how much carbon dioxide, and we know how much water. Well, shoot, how much water or how much oxygen would you use? Okay, we can do this a super shortcut. Here's why. Remember, your atoms have to equal. Oh, I feel a list coming on. Okay, you ready? Our atoms, total atoms on both sides, have to equal. That's our balanced reaction. That means our weights have to equal. That total weight on both sides has to equal. Our moles do not have to equal. Now, in this case, they do, but they don't have to. So why do we give a crap? Well, we can use a shortcut right now. If our weights have to equal on both sides, well, now our math just got easy. All right, let's do this. How do we care if that matches? Let me erase here for a second. Okay. It matters because let's add these two up. Now we have our total products. So I'm going to take that 22.5. Oh, let's enter it on the calculator, right? Okay. Plus 27.4. And I've got 49.9 total grams product. Okay, now we can't create or destroy matter. So what does that mean? That means on the reactant side, we have to have 49.9 grams total. Well, we've only started with 10 grams of methane. So that means the other 39.9 grams has to be oxygen. Okay, awesome. So we actually just figured out everything in this reaction. We figured out that if we took 10 grams of methane, 39.9 grams of oxygen, we are going to make 27.4 grams of carbon dioxide and 22.5 grams of water. That is awesome. All right, let's turn right around and do this again. I'd like this process to feel repetitive, so we're going to do it again. Now, how do you make these questions pretty mean? There's a couple ways. The first one, let's put in some naming. I love it. For the rest of the semester, I'm just going to give you names. I had to sip my coffee for that one. This is going to be so much fun. All right, so now I love it because this is putting in some of Unit 1, Unit 2, and Unit 3 all together. So the first thing we have to do is take each one of these and draw the formula. So you may want your common anion sheet. Remember, that's how we kind of started naming things right before we left for spring break. So I am going to look at lithium hydroxide. Don't just Google it. Grab your common anion sheet. Hydroxide on there is an OH with a -1. And then your lithium, look at your periodic table. What's your charge there? +1. I love it. So that is your lithium hydroxide. That is an ionic bond. And you know you can use your charges for that. All right, that's how they're going to go together. So your formula is lithium hydroxide. And then carbon dioxide, I can tell right away from the dye that this is a covalent bond. So that is carbon dioxide. All right, lithium carbonate. All right, lithium we already know is a +1. What is carbonate? Check that common anion sheet. And what is the charge? Oh, it's a 2. So how many lithiums do we need? 2. And then our dihydrogen monoxide, that screams covalent bond, that is our water. Okay, I love it. So now all I did was add a step before we have our trust issues. So you grab your yoga pants and light a candle. Let's find our balance. So first we had to write those formulas. Now we have to balance. So I haven't even read the question yet. And yet we still had some work to do. You can see why I love that. All right, so let's go ahead and balance here. Whew, this is going to be a tricky one, huh? Let's start to spell out what we've got. We've got 1 lithium. We've got 3 oxygens. We've got 1 hydrogen and 1 carbon. All right, I've got 2 lithiums. I've got 4 oxygens. And how many hydrogens? 2 hydrogens and 1 carbon. All right, so first thing is glaringly obvious. We need to do something with our lithium. Let's put a 2 out there. Let's go to 2 lithium. Except what did that jack with? Our oxygen. So now we're at 4 oxygens. Okay, that's fair. And then what did that do to hydrogen? Now we're at 2 hydrogen. Wait, I think we just balanced. Huh. Well, that wasn't too bad. All right, so take a screenshot of that. I'm going to erase our little process there. All right, now we've got a balanced reaction. Now let's read the question. Let's see what we're going to do. All right, let's see. If we're starting from 10 grams of lithium hydroxide, I'm going to write that right up there. And we have an excess of carbon dioxide. Let's figure out how much of our products we can actually make. All right, I love it. Let's do it. I like to start with the one number I'm given. We're only given 10 grams of lithium hydroxide. And we're asked to calculate the 2 products. So let's just do the first one first. Remember, you can't use the mole ratio without moles, so let's put moles in the middle. So let's convert that lithium hydroxide to moles. How are we going to do that? Well, we need our molecular weight. So grab your calculator, your pencil. Let's figure that out. All right, lithium is 6.941 plus our oxygen 15.9994 plus a hydrogen. All right, I am getting 23.9. Oh man, I'm running out of space. Hang on, let me write smaller. All right, 23.9483. Done. All right, now we want to convert that lithium hydroxide to lithium carbonate. How are we going to do that? Our mole ratio. All right, how many moles of lithium carbonate? Only 1. Our moles of lithium hydroxide? 2. All right, now we're left with moles of lithium carbonate. Let's convert those to grams. All right, grab your calculator again. Let's do this. We've got 2 lithiums. 2 times 6.941 plus a carbon, 12, plus 3 times our oxygen. And I get 70, I'm going to write it up above, 73.8912. Awesome. All right, let's cancel that. And we're going to be left with grams of lithium carbonate. All right, let's plug this into our calculator. Hit pause if you need to. But I'm literally calculating with you, so you're probably faster than me. I'm going to divide by 2 and multiply by 73. I am getting 15. What did I do? Okay, I am getting 15 0.4272383 grams lithium carbonate. And then let's go ahead and do 3 sig figs again. We've got 3 here. Let's leave our answer in 3. That's going to be 15.4 grams. All right, sparkle pen. All right, do you see the pattern? Well, let's turn right around and do it again with water. That's it. All right, let's go ahead and screenshot this one. I'm gonna erase the sparkle pen part. I know, sad, right? And then let's do the same for water. We're going to start the exact same way. We're given 10 grams of lithium hydroxide. We need to get to moles. So let's do exact same beginning. Okay, now what changes is your mole ratio. You're going from lithium hydroxide to water. And then we're going to convert our water. Okay, well, we have that molecular weight already, don't we, from the last problem? We want grams of water from moles of water. All right, let's fill in some numbers there. We've got 2 moles of lithium hydroxide is going to make 1 mole of water. And then our grams of water was what, 18 something. Let's scroll up. We had it in our last problem. 18.0152. All right, grab your calculator. Let's do it again. I'm going to just go ahead and go right to 3 sig figs, 3.76 grams of water. I love it. Now, if we felt like it, we could total that if we wanted to, and then we could figure out how much carbon dioxide was used. All right, I hope you're starting to see a pattern. You know, we really are doing the same thing for each one of these. We're converting to moles, so we're going from grams to moles. And then we're using our mole ratio. And then we're converting back to grams. I love it. And each time, if you look at your units are helping you solve your question. And you're ending with what the question is. That's the one you want. And you're starting with what you're given. This is just one fancy unit conversion. All right, let's do it again. I love it. Okay, now, how else do you make this hard? You put naming in. Or you know what else, just hold your seats. You already know where this is going. What if we have to do a unit conversion before grams? Oh, so this would be one of my favorite problems. What if, shut up, we start from 10 pounds of our reagent instead of grams, and we've got the names. This is as fun as it gets. This is going to be so much fun.